Consider the reaction below. If 454 grams of sodium hydrogen carbonate were decomposed into carbon dioxide, what volume of carbon dioxide would be produced at STP? Well, the first thing I see in this problem is a chemical reaction that needs to be balanced. If I have two sodiums on this side, I need a coefficient of 2 to make two sodiums on the reactant side. We have two carbons and two carbons on the product side, so the carbons are balanced. I have two hydrogens and two hydrogens, and last but not least, I have 6 oxygens and 3, 4, 5, 6 oxygens. We're now balanced. So now I can start looking at the problem itself. I have a situation where I'm dealing with STP. STP stands for standard temperature and pressure. The standard temperature was 273 Kelvin, and the standard pressure was 1.000 atmospheres. Now, I have one pressure, one temperature, and one amount of chemical. But for the ideal gas law, since we only have one set of conditions, the gas law that we should be using, the ideal gas law has very specific units that it requires us to use. And while Kelvin and atmospheres are perfectly fine, grams are not a unit that we can use directly. We need to convert it into moles. So I start with my 454 grams of sodium hydrogen carbonate, and I want to convert that into moles of sodium hydrogen carbonate. So how many grams do we need? How many grams equals 1 mole? To find that out, we go to the periodic table. Sodium has a weight of 3, hydrogen has a weight of 1, carbon weighs 12, and oxygen weighs 16. So, if we go back, we have a single sodium at 23, a single hydrogen at 1, a single carbon at 12, and 3 oxygens at 16 apiece. If we add these up, we should come up with 84 grams per mole. So 84 grams of the sodium hydrogen carbonate equals 1 mole of the sodium hydrogen carbonate. So if I take my 454 and divide it by 84, I come up with 5.40 moles of the sodium hydrogen carbonate. However, we have a problem. Even though this is in units of moles, the problem asks for volume of carbon dioxide, not of sodium hydrogen carbonate. I need to do some stoichiometry and convert it into the right chemical. So my 5.40 moles of sodium hydrogen carbonate needs to be converted to moles of sodium hydrogen carbonate, reacts to form 1 mole of carbon dioxide, giving us 2.70 moles of CO2. The 2 and the 1 are coming from our balanced reaction, where if we see no number in front of a chemical, we assume it to just be a 1. Okay, so now we have our pressure, our temperature, and our number of moles all in the right units. We can start with our ideal gas law. The pressure at STP is 1.000 atmospheres. The volume, well, that's what we're trying to find in the problem. What volume? So I'll leave that as a V. Our number of moles, 2.70 moles. The gas constant, which you should memorize, is 0.0821 liters atmospheres per mole Kelvin. And finally, our temperature of 273 Kelvin. So if we solve for V, bringing the 1 to the other side, well, any number divided by 1 stays the same, so I can simply take my 2.70 times 0.0821 times 273 to give me the final volume of 60. We have 4 sig figs, 3 sig figs, 3 sig figs, so I'm going to call this 60.6 liters of CO2 as my final answer.